Okay, so what we can do, we can look at the stat task. I think it's a discussion board that's due, ooh, when is it due? Let's see. I'll share my screen and look. We'll go to home, and the discussion board is due right here, November 4th. Okay, so here is the question. A solar company claims its customer will save an average of $80 per month. A consumer protection agency feels this claim is too high. If they randomly select a sample of 36 customers and the mean savings was found to be $73 with a standard deviation of 1670, perform a hypothesis test. So my first question to you guys is, this is a test on means. Let me go ahead and write this down because Alex can't hear. So, this is a test on a mean. Is it a z-test or t-test?
Well, we have a standard deviation for the t, right? Right? I don't know how to back up out of it.
And then why?
Why is it so big? I want to minimize it. It's way too freaking big. Is it big? Well, you said, I know the standard deviation. I know the standard deviation.
You can't see my chat. There we go. Okay, so because they do not give, because they don't give the sigma or the population standard deviation, I'm going to write this down. So there's no sigma. So what you're given here is the x bar, here is s, and then this is mu, and basically it says to determine if the actual savings is less than the company claims. So we're seeing the null is it equal to 80? And then the alternative is less than, so its mu is less than 80. And because we have no sigma, this is a t-test. Okay, so the null and the alternative, well, I kind of got that right here. And then I want to find the critical value at the 5% significance level. So let me actually, I'll put it on my screen, I'll put it on my screen behind me here. I have the null, stop sharing, hold on. Okay, so I have the null is mean is equal to 80. The alternative, the mean is less than 80. And it's asking for my critical value. All right, so so I said that this is going to be a t-value because sigma is unknown. All right, so I can create a, we can go down a little bit here. I can create this is basically my normal distribution. These are all samples of size, I have to go back, 36, n equals 36. And I can translate that into t-values. So so for basically my mean of my means is equal to my, I'm going to assume that it's my null. I'm assuming the null is true. Let's see if I can get that in there. Okay, so you assume the null is true. And so we assume that the mean of the means is 80. And then our standard deviation of x bar is also called standard error. And that's equal to s over the square root of n. I have to look it up. Let's see. S is 1670. And square root of n, square root of 36. So I have 1670 divided by square root of 36, or approximately 2.78. So I'm going to go 2.78 above the mean in one direction. All right, and that's t equals 0. That's one standard deviation above the mean. Sorry. And then we have negative one standard deviation below the mean. That's 80 minus 2.78, or 77.22. Okay, so I just set that all up, but the question was, what's my critical value? My critical value is my t value, and it's the following. It's equal to x bar minus mu over s over the square root of n. So this is 73 minus 80 over 2.78 over the square root of 36, or approximately, let's see, that's negative 7, approximately negative 2.52. Sorry, negative 2.52. This is my test statistic. It comes from my sample. And so if I put it over here, this is basically saying my sample, so at negative 2.52, that was 73, and this is where my sample is, and that's my test statistic. Then for my critical values, I need alpha. So I'll do that in a different color here. So if I have alpha, and I go back to my problem, and I'm not sharing that right now, but my problem is alpha is equal to 5%. This is a left-tailed test. So my question is, what is this t-value if this is 5%? It's the whole 5% in the left tail because it's a left-tailed test. So there are a couple of ways that I can get this critical value. One way is to use my t-chart. And on my t-chart, so hold on for one moment here, I want to find the area left of this t, this critical value, is equal to 0.05, and the degrees of freedom are 36 minus 1, or 35. Okay, can't see that. Sorry. The area left of this t-value, or the critical value, is 0.05, degrees of freedom, 35. So one way to get this critical value is using my t-chart. Let's see, let me go back to share screen. I'm going to go to my t-table. Oh, did I not open my t-table? Hold on. Let me open the t-table. Okay, so one way is I'm going to look for 0.05. I'm going to look for 0.05. 0.05 is actually to the right, so this will be positive, And then this, if it's 0.05 to the left, will be a negative value. All right, and then I'm going to look for degrees of freedom, 36 minus 1, or 35. So bear with me. I can go down here. Clear. 35. Okay, there's no 35. Of course, it's in between 30 and 40. And which column was I in? The fourth column. 30, 30, 40, and it was right here. So my critical values are someplace in between 1.697 and 1.684. So I would say, I don't know, let's say 1.69, let's say, to round. And so in other words, let me just stop sharing. I can write it on here. So in other words, working on here for my critical value, I just said, what was it? Negative 1.69. Okay, but that's not very, hard to see it. That's not very accurate because I used a table. So the other way that I can find the critical value is if I have a calculator, I can do, let's see, inverse T, and I'm going to go 0.05, and then the degrees of freedom, 35. And so the way that I would do that, I'm not sure if I can share it on here. Let's see. Share content. Oh, I don't see that I can actually do it on, I can't actually show you on the computer how to do that, but basically you're going to go to second theirs, and then you go to inverse T. I'm going to type in 0.05 and then degrees of freedom, and I get negative 1.689. So this is negative 1.689 also the critical value. Okay, so the idea here is my test statistic lies in my critical region. This is the alpha. It tells me anything in here is unusual, less than a 5% probability. So if I get my sample in here, I say reject the null. There's sufficient evidence to show a difference. Okay, so that's basically reject the null, sufficient evidence to show the mean was less than 80. Okay, so back to sharing hypothesis tests. I think it's that one. Okay, so we've got the null and the alternative hypothesis. The critical value, so if I were to write this, I've got the critical value. The critical value was negative 1.689. I have the test statistic. The test statistic was negative 2.52. Now I need to do the p-value, so I got to do it again. All right, I've got to do this whole thing. I mean, by the way, I've already concluded my hypothesis test is reject the null. There is sufficient evidence to show the mean is less than 80. Okay, so by the way, so just doing the critical value and test statistic, I've already rejected the null and said that the mean is different or less than 80. But now I want to do a p-value. So one of the easiest ways to do a p-value in this, if you have a TI-84, would be to, you're going to pull up stat. Let me do it while I'm doing this. Then tests. Then let's see, this was a t-test. I have stats. And so I'm going to put in the mu0 is equal to 80. I'm going to have x bar is equal to 73. I'm going to have s was equal to 1670. I have n was equal to 36. And then we want to have a less than for our alternative hypothesis. I click enter or calculate. It gives me t equals negative 2.51. I just calculated that. That was x bar minus mu over s over the square root of n. I calculated it by hand, but my calculator did it also. And then it gave me p equals 0.008. Okay, that was using my calculator, and you can do the same thing in Staccato. But the idea is, for here, you're comparing the p-value with alpha. And so you're saying, you know, less, greater than, or equal to the significance level. And so in this case, 0.008 is definitely less than our significance level of 0.05. We say this is unusual, and therefore reject the null, right? That there's sufficient evidence to show that the mean is less than 80, etc. Okay, so any questions on that one? I'll go ahead and might as well, since we're here, I'll do type 1 and type 2 error. Type 1 error is to reject a true null, and a type 2 error is to fail to reject a false null. So in other words, there's two mistakes you can make. Like you can put an innocent person in jail, or you can let a guilty person go free, right? If you're doing it, if you're saying that this is a innocent person in jail, and this one is let a guilty person go free. Okay, so here, what are the consequences? Well, if we made an error, it was a type 1 error because we rejected the null. So maybe we say that the mean is less than 80 when it's not. That's type 1 error. If we made an error, which we don't know that we did. Okay, if we made a type 2 error, we didn't here because we didn't fail to reject the null, but if we made a type 2 error, is that we fail to show the mean is less than 80 when it actually is. It's supposed to. Okay, so those are type 1 and type 2 errors. Let me cancel this. I don't want to save this and give all the answers. Okay, so let's see. That's for the first one, or at least actually, I guess, so that's now I pretty much answered 1 through 6 for you. I want to see if there's something more like what we're doing tonight. Here we go. Okay, so I'm going to skip a couple because I only have like 10 minutes left, and I want to show you something that I believe you're doing tonight. Is tonight the 2 proportions? Look. Hypothesis test independent proportions. Okay, so this is more like what you're doing tonight. And the big thing here is that it says 69% of people said one thing, 52% of another people said that they brought their phones to bed with them, and then we want to see if there's a difference in the proportions. Okay, so I'm going to show the screen. I'm going to show my whiteboard instead of the screen here. So I'm just going to stop sharing, and I'm just going to write down everything that it says on the screen. So. So when you're doing a test of proportions, the null is always, the two proportions are the same. Whoop, can't see that. The two proportions are the same. The alternative is, in this case, I believe it's different. The two proportions are different. Yeah. Okay, so that's the null and alternative hypothesis. And then we want it asks for a test statistic and, by the way, critical values. The test statistic comes from my sample. In this case, it's a Z test statistic. Oops. But right, it could either be T or Z so far. And my critical value, it's also Z, but it comes from alpha. Okay, so my sample, so basically, let's see what we have here. So I'm actually going to, let's see, I will put up right now a formula sheet. Can I share documents with you? Let me just see if I can share documents with you on Zoom. Invite, stop recording. No. Okay, so I'm going to go ahead and share a document. With you. I'm going to put it on these hypothesis tests. I'm just going to put in a formula sheet. Share screen. Okay, so I'm going to put in this formula sheet. Files, upload a new file. Where's formulas? This is not in alphabetical order. I knew I put it somewhere. Gosh darn it. Let's try that. Upload. Okay. So on the same, on the discussion board here, you're going to find the formula sheet. So let me hit save so you can see it. And you can open it up, but I'm going to go ahead. I'll open it up here. Oh, here. Might as well just open it up here. Okay, so these are formulas from the entire semester so far. We have mean, standard deviation, discrete random variable, binomial. We have z-score. We have of just an x value. Then we have z-score for an x bar. Then we have t-score for an x bar. Then we have z for a proportion. All right, and then now we're getting to these other test statistics. And actually, it's almost in opposite order. But this is the one that we want. And I'll talk about that a little minute. But it's basically the sample proportion for the first group, the sample proportion for the second group, and then I'll go through the pooled estimate for one, pooled estimate for two, and then the sample sizes for each. Okay, so I just wanted to bring that up so you can see where to see these things. By the way, there's confidence intervals down here too, sample sizes, and I'll put anything else that you may need in there for later. But that's up there now. So let me see, I'll stop share. And so for my Z statistic is p hat 1 minus p hat 2 over the square root of p, PE, which is pooled estimate, minus 1 p, PE. All right, all this stuff. Okay, so I'm going to plug all this stuff in as possible, as you know, what I can do. Let's see. So I'm going to go back to my hypothesis tests and read it again because I've lost my. Okay, so we have the group of 20 to 39-year-olds, we'll call them. That group, when 258 people in the age group were surveyed, 69%. So for the 20 to 39, 69%, or of the 258 people brought their phones to bed. Of the group, 40 to people in their 40s, 40 to 49, there was 52% of the group of 129 people brought their phones to bed. Okay, so we're going to do, we'll do this as the 40s, and this is the 20s and 30s, 40s, and basically we're saying, are those proportions different? So let me go 0.69 plus 0.52. Sorry, minus 0.52. All right, so that is the difference between, in other words, there is a 17% difference. Oops, sorry. There's a 17% difference between the two samples. All right, we're assuming that there is no difference. The null is there is no difference, but there is a difference in the samples. Okay, so how do I do pooled estimate? Well, remember, p hat equals x over n. Okay, so this is 0.69 equals x over 258. In other words, 69% of the 258 people, come on, clear, 69%, 258 people, approximately 178 people out of the 258 people, whoops, sorry, you can't see that, 178 people out of the 258 people, that's 69%. I do the same thing here. This is 0.52, 52% of 129, multiply these two, and I get 0.52 times, I get 67 out of the 129 people. And my pooled estimate, PPE, is basically the total that bring their phones to, the total percent that bring their phones to bed. All right, in other words, this is 178 plus the 67 over the total number of people, 258 plus the 129. Because I don't know the proportion, and I don't know the population proportion, but I'll estimate it just saying these are all the people that brought their phones to bed.
Okay. Just leave a little bit of water in their mac and cheese.
258. 255 divided by 387 gives me 0.633.
So it's
This is my pooled
128 out
proportion.
of 258, and then it's 0.52.
All right, and that's what I'm going to do right here. I'm going to plug this in. 0.633, 1 minus 0.633, N1 and N2, that's 258 and 129.
That's your pooled proportion.
Okay, so I get, this, by the way, is my test statistic. It came from my samples. I'll go ahead and get the answer. Let's see, we have 0.633 times 1 minus 0.633.
So 0.6952. Okay, so 0.69 minus 0.52 over.
All right, let's see, and then I have that divided by times 7. I believe I get 3.27. That's 3.27. Okay, so coming back to my sort of my critical value and my normal curve here, I'm saying I imagine that P1 minus P2 has a 0 difference, right? Because that's what the null is. There is no difference. There's Z. But what I actually got was a 17% difference. I don't know where that is yet, but I have Z is 3.27. And that was my test statistic. All right, and then I compare that to my critical value. My critical value, since it's two-tailed, I have alpha over 2 in each tail. It's a 5% significance level, so that's 0.025 in each tail. And again, I can either go to, my meeting's going to end in 10 minutes. Ah. Oh, sorry. Okay, Alex, do you have a particular, Alex, do you have a question? I didn't see hand up until now. Go ahead and type it in if you have one. The meeting will end soon. Okay, so if you want to put this in your calculator, please see the right side. See if I can get it over here.
I don't know what the fuck it all means, but I got it. 0.17 over, oh, no, watch out. Okay, over 0.0519 equals 3.27. I don't know what I got, I don't know where I got it from, but I got it.
Okay, so I'm not sure if you can, if you're gonna do this on a calculator, can you see this? Let's see. You're gonna do, tests. You're gonna go to stat, test, and it's a 2-prop Z test in your calculator. Let me see what you have to write in there for that. Where x1 is equal to 178, n1 is equal to 258, x2 is 67, n2 129, 178, 258, 67, 129, and this is not equal to okay, I get Z is equal to 3.28. I get my p-value is equal to 0.001. In other words, your p-value is less than alpha. Alpha, this is 0.025, this is 0.025. This means that my test statistic is lying in my critical region. It lies past my critical values. Those are my critical Z values. It lies in the critical region, therefore, right here. Reject the null. Therefore, show that, right? Therefore, show that, in fact, P1, there's a significant evidence or sufficient evidence to show that the two proportions are not the same. We could see they weren't the same from the very beginning. It was 69%, 52%, but we're saying, is that due to chance or actually statistically significantly different. And in fact, yes, they're different. 40-year-olds bring their phones to bed at a different rate than 20 and 30-year-olds. All right. I think I'm going to lose you guys in a minute. The Zoom session will end. Hi. Okay, so
Don't even get it.
anything, go ahead. I'm on online office hours. You guys, so I'm just ending it right now. So you go ahead and have a seat. Do you still need to copy anything? I'm gonna lower your hand here. So if you have any questions on step 4, I'm happy